SQL Server Statistics. You may have heard of them, you may have updated them, but the purpose of this video is to go into some more details in what they're for and how to use them. Maybe somebody said to you one time, maybe you should update statistics. Or maybe you opened up that set of folders under a table and you said, I know what columns are and I know keys and I know what those are and those are, but what are those? A typical scenario is you have a performance issue that you need to research, and maybe you narrow it down to a few queries or maybe even one in particular. So you start experimenting with it in development and come up with an execution plan, and the whole thing looks fine. So now what do, right? So you do the same thing in production. You get an execution plan in production. Maybe you work with your DBA or something like that. And the plan is different. Why? Why are they different? The suspense must be killing you. Make a database first. And I want to make a table. And I'll use the this type, data type field from all columns, system all columns table. But I don't want to use a number, so there, that's better. So obviously this isn't very useful data because it's just a lot of duplicates. And I want this to be rerunnable, so I will delete this table. There, that's better. Yeah, let's put an index on that. And let's see what was created. So here's the index, and here's the statistics folder, and you can see that when the index was created, so were statistics. So let's see what this looks like. And details has the fun stuff in it. And you can see this range high key is the data types. And then there's this EQ rows. And this looks to me like it's the number of occurrences for these. So int has a high number and probably occurs a lot more. Let's see if that's true. So yeah, you can see int is 2729, and so is this. Now I want to point out image here, which has 8 occurrences, and here it is here. And I'm going to use this as an example in this video. So I'll delete that index. And if I refresh statistics, that goes away too. But now I'm going to run that query again. And statistics come back. And if I look at this, you can see it looks pretty much the same. So even though I don't have an index, the query engine will still create statistics. Okay, I want to look at a plan, but I want that plan to contain a lookup. So I'm gonna need this index back in there. And I'm also going to add a field. So what I did here is I chose to include an actual execution plan, and sure enough I have this lookup. So if a query plan uses the index and the select includes a field that's not in the index, then it has to do a lookup to get that additional field. And it doesn't have to, it really depends on the plan that the query optimizer selects, but in this case it worked. Okay, so I'm mousing over index seek and I get this nice tooltip, but I can't move my mouse or it disappears. But if you look through this list, you'll see actual number of rows and estimated number of rows, and they both equal 8. I used an actual execution plan because I wanted to compare those two values. But if you're in the process of tracking down a performance problem, I'm sure you can understand there's really not much use in doing this in a development environment because that actual number of rows isn't going to match production. All right, so let's try throwing off those values by inserting a whole bunch of image rows. Now I want to insert exactly 2490 because I happen to know the magic number because I've been doing some experimenting here. Okay, now if you look at those same two rows, actual number of rows is 2498 and estimated number of rows is 10. So this time the estimation is way off, and that's because the statistics are out of date. Okay, so now I'm just going to insert one more row. That's a very different plan, and I've lost my lookup. And when I check my actual number of rows and estimated number of rows, they are both 2499, so they match, and that's because the statistics got updated automatically. So the way this works is the query optimizer picks a few plans that would work and then comes up with a cost estimate for each plan, and whichever plan costs the least wins. you can see the estimated costs listed in this tooltip. So before, when we looked at the plan and it hadn't changed, that's because the statistics hadn't gotten updated. And the query optimizer saw that the statistics were the same and it just used a cached plan. The lesson here is that statistics get updated automatically as needed, but that's not always the case because some databases don't have that setting turned on, so I'm going to check that. I'm just executing the system databases table, and if I scroll over, I'm looking for a column with a lot of ones in it. So here we go. Is Autocreate stats on? And is Auto Update stats on? And I can see that those are both set on for all of my databases. So remember I deleted my index and the statistics got created anyway? Well, that's what this Autocreate stats on is for. If you find that any of these are 0, you can turn them back on. I'm just going to paste in the instructions instead of typing them. So one of these is for create and the other one's for update. I would not recommend turning them off unless you're doing some kind of an experiment, because it's good to have them on. In fact, sometimes I wish the query optimizer would update statistics more often, because a lot of times a query takes longer than it would take to just update the statistics. But you can update them yourself. And it's just that simple. But this instruction actually has a lot of parameters that make for a nice surgical instruction. Another one is SP update stats, which I would avoid because it's not nearly as surgical. Okay, so I'm going to do this again, except this time I'm going to use a table hint to force a scan or a seek. Okay, now that I have them both in one execution plan, I can compare the total costs of these two queries. See, it says query cost relative to batch. These two add up to 100. This one takes 10 times longer to do than this scan. I should point out that cost isn't necessarily, the time that it takes to process it. It could take a lot of things like how much of the CPU it's taking up or other resources. And another issue is that this table we're querying is small. So if I were to actually try and time this out, it's only like 10,000 rows. If I were to try and time this out, these two queries would probably come out pretty close. This wouldn't necessarily take 10 times longer. But if you do try and time it out yourself, don't forget to clear your cache with drop clean buffers. And did you notice this green text here? If I mouse over it, it's telling me that I should include the ID column in my index. So let's try that. All right, that made a difference. Before, this one was taking 10 times longer, and now it's running 5 times faster. I'm comparing this. This is about 80, this is about 20. So if you're not familiar with including columns in your index to get rid of lookups, it's a good thing to know. All right, so that's the important stuff. But I'm going to try and go a level deeper here and try and find some of that data. If you're like me and you like to automate tasks, it helps to know where this data comes from. I'm going to do queries on the system tables. The first clue I'm going to follow is the names of these columns here in this histogram, and 2 of them begin with range. So let's look for that. DM DB stats histogram. Let's try that. Parameters were not supplied for this function. So this is a dynamic management function, and I know I should join in the system stats table with a cross apply, but if you're not familiar with cross apply, maybe I should explain it to you, because I think it's very useful, especially for table valued functions like this one. So what I want to do is something like this. And I would normally, if I were doing a join, I would need these, on predicates here, but this isn't going to work. And this is just what the cross apply is for. I just replace the join with cross apply, and I get my results. So cross apply kind of works like the table that's on the right side of the join is kind of like a subquery, in that you're not using predicates. Instead, you're using parameters within what you're querying there. If I scroll over here, this looks familiar, right? And you might think that you could compare this to doing that select that I did earlier. But this is a small table, only 10,000 rows, and if it were any bigger, you would start seeing range values, which makes this a lot more complicated. If you read up on this a little bit, then you'll see how this works. It actually is supposed to work kind of like a histogram. That's why it's called that. And so if you wanted to try and figure out if your statistics are out of date by doing some kind of a comparison like that, it might be more difficult than you had planned on. So that's that. Let's see if we can find the data that the query optimizer uses to decide if statistics need to be updated. There are a couple of other dynamic management functions that we can look for. This is the one that I'm interested in. if I look way over here, I see modification counter, which is 0. Let's see if we can fix that. So now it's showing the 2490 rows that I inserted just before the statistics got updated. Before 2016, there was a nice, neat formula that they used for how to calculate if statistics are about to be updated. And the formula is 20% plus 500. So here, that comes out to 2491, which is just one more than the changes that I made. So you can see how I figured out what number to use, and then if I insert just one more, the statistics get updated. Now, I don't know what the formula is now. I'm sure it's more complicated because I haven't found it yet, but I'm using 2017 here, so obviously it can't be that different if this estimate worked so well for me. The bottom of my slide is cut off. So hopefully you learned a few things here, like how to turn on automatic updates on your database just in case they're off, and how to check if statistics are up to date by using that query plan, and how to force statistics to get updated. And along the way, I hope you learned a few other things, like what cost is for, and how to avoid lookups by including additional columns in your indexes, and how to force a scan or a seek, and how to use cross-apply, and maybe using system tables to find things, and also what dynamic management functions are. And one last thing is, this whole time I didn't use the set statistics IO on, which if you're investigating a performance issue, this is a really useful thing that I'm not going to explain here. It wasn't needed for this video. So that's it. Thank you very much.